Fire. It's one of the greatest hazards you can face at sea. Even a very small fire, and they all start small, can quickly become a major disaster. It can threaten not just the vessel and its cargo, but also your life and the lives of your workmates. What's more, even if a fire doesn't kill you, it can change your life, your appearance, or your ability to provide for yourself and the people who depend on you. It's vital to be proactive about fire safety, and that includes helping to foster a strong safety culture amongst everyone on board. That safety culture is especially important where machinery space fires are concerned. So, think fire every day you are on board ship. It's key to keeping yourself and your workmates safe. In this programme, we look at the causes of machinery space fires, how they can be prevented, and how to tackle them if one does happen. With an abundance of heat, air and fuel, machinery spaces contain all the elements needed to start a fire and sustain it. And because the engine room is at the heart of a vessel, once a fire takes hold, it can spread rapidly and become completely out of control in a matter of minutes. Once that happens, the ship could lose power and the ability to maneuver. Because of this, naval architects build in a considerable degree of safety at the design stage. They have three aims: to reduce the chance of fires starting, to prevent them spreading, and to allow the crew to contain and extinguish the fire before it can endanger the vessel. These measures include running electrical cables through ducts to shield them from heat in the event of a fire, installing splash panels and double-skinned fuel oil pipes to protect hot surfaces from high-pressure pipe failure, fitting insulation to retard the spread of fire, and to provide additional protection for crew accommodation and cargo spaces, and providing fire-resistant doors, airtight hatches, and individually controlled ventilation dampers to seal off the machinery space and deprive the fire of air. They also make sure that the ship's design includes a fixed installation, perhaps more than one, and more than one type. These systems are specifically designed to extinguish a fire very quickly. Types of fixed installations can vary from ship to ship and can include high fog, sprinkler systems, drencher systems, medium and high expansion foam, and carbon dioxide or CO2 installations. In an enclosed space, CO2 works by smothering a fire by starving it of oxygen. Medium and high expansion foam works in a similar way. High fog systems deliver microscopic droplets of water that disperse heat and rapidly cool the fire, as well as smothering the flames. These safety features are there to protect the vessel and its crew. However, their effectiveness depends on regular inspection, maintenance and testing. Seafarers who ignore these tasks put themselves and their fellow crew members at risk. There are a number of different types of machinery space fire. The most common of these is fires caused by oil leakages, which account for more than half of all machinery space fires. Scavenge fires, if large enough, are particularly prone to extending through hotspots on the scavenge trunk. There are also crankcase explosions and fires involving the funnel, uptake, economizer or superheater. Funnel fires, because of their visibility to everyone on board, can very quickly lead to panic. This makes them even more dangerous, as panic can cost lives. Some fires are caused by electrical problems or component failure. There are also switchboard fires involving high current and boiler fires. Though every machinery space fire results from a combination of different circumstances, they don't just happen. Machinery space fires occur because heat, air and fuel have been allowed to combine to create combustion. Many engine room fires are caused by fractured high-pressure oil lines. However, there are a number of other possible sources of ignition. These include sparks from angle grinders and welding equipment, high-voltage electric cables. Be particularly careful of the bus bar and any red-coloured cables. The hot, dry atmosphere in a machinery space, which is ideal for the build-up of static charges. And engines, pumps and other machinery which generate heat. Remember, hot surfaces can also vaporize flammable liquids, changing a safe product into an unstable combustible gas. Changing fuels is a more frequent operation now that emissions regulations have changed. This can lead to problems, such as distillate fuel leaking from pump glands and seals, for instance, as well as other problems with both main and auxiliary engines. There's more detail about these types of fires in the workbook which comes with this series of programs. Every ship has a regular program of maintenance, but in a machinery space, any repair carries a potential fire risk. For instance, removing the protective lagging exposes hot surfaces and creates a source of ignition, if left even briefly unattended. And temporary repairs, using non-standard or below-standard components, can also produce the conditions for a fire to happen. The dangers of machinery space fires are very real. They are always serious, and you must take every precaution to avoid them happening. Following laid-down working practices will minimize the hazards and keep both the vessel and the crew safe. You must have the proper tools and authorization before starting a job. Procedures like carrying out a risk assessment and obtaining hot work permits, or arranging the isolation of oil or electrical feeds through the lockout procedures, significantly reduce the risk of something going wrong. That's what they're for. Test the fire alarms and fire and heat detection systems regularly, and replace any faulty components. Inspect fire extinguishers at recommended intervals, and always recharge them after use. The fixed installation should also be regularly checked to make sure it's working correctly, especially after the bottles have been serviced. This could include sonic testing of gas content in the cylinders, the inspection of mechanical linkages, valves and cocks to ensure they have been reset correctly, and the periodic testing of foam samples. You can find more information about this and other topics covered in this program in the workbook. Regular, realistic fire drills are vital to the safety of the crew and vessel. Machinery space fires can generate a lot of dense smoke, so exercises should include search and rescue in these conditions. Masks with opaque lenses to simulate poor visibility in smoke may be useful for these. In a fire, fear and panic can make crew members do things which could threaten their own lives. That's why thorough training is so important. In thick smoke, it's easy to lose your bearings and move closer to danger rather than away from it. Fire can break out on the best maintained vessels, even those run by the most professional of crews.
Big fire, small fire?
If the fire occurs in the engine room, temperatures can soon reach more than 600 degrees Celsius. Within minutes, a fire can turn into a raging inferno, and that can lead to serious injury or even loss of life.
Smoke detected in steering gear room.
That's why level-headed, considered judgment is vital. After the alarm sounds, you may have very little time before the fire is out of control. Automatic fire sensors can detect a developing fire very early on. Just because you cannot see smoke or flames, you should never treat the fire signal as a false alarm. Follow your training when dealing with a fire emergency. Remember the letters making up the word fire. Find it,
Fire! Fire! Fire!
isolate it, provided that this only takes a few seconds, report it, which can include triggering a fire alarm,
Hello, Captain, I discovered a smoke in the main deck.
and extinguish it. But only if it is small enough to be dealt with by one portable extinguisher. If that's not the case, then E stands for escape.
Make sure that all ventilation...
After the initial discovery of a fire, the crew's first task is to isolate it by using emergency shutdown systems to cut off the flow of fuel to the fire and closing all vents and dampers. Evacuate unnecessary crew members from the machinery space. It's essential that everyone goes to their muster stations.
Chief Engineer. Here. Here.
The first task of the officer in charge is to carry out a roll call.
William. Here.
At all times, effective command and control will maximize the effectiveness of the firefighting and support teams by coordinating their efforts.
Yeah, I've just heard from the first response team.
The master, the chief engineer, and the team leaders monitor the spread and intensity of the fire minute by minute.
Okay, stop boundary cooling from deck number 1.
They need accurate and up-to-date information. They should maintain communication with nearby ports and consider the possible availability of shore-based firefighting teams. But whoever is to tackle the fire, there will only be a limited time in which to gain control over it. So, if the fire can't be brought under control by the firefighting teams on board, any team which has arrived from a shore installation or any fixed installation which does not require the evacuation of the area, then the master or the officer in charge must decide when it's the right time to use any fixed installation which does require evacuation. When that moment arrives, clear the machinery space and evacuate any firefighting teams, and allow time for this to happen. As soon as everyone is out and accounted for with a full roll call, batten down all the hatches, fireproof doors, and all engine room and funnel vents, and close all quick-close fuel valves on the fuel tanks.
Bridge, Chief.
Doors are closed, ventilation is shut down, and all vents and dampers are closed.
Once the machinery space is sealed, the master can order the release of the fixed installation. This will have an immediate effect, but the fixed installation must be given time to work. This could be as long as a few days, because even though the fire has been extinguished, you must allow time for the area to cool down so there is no chance of reignition. Many masters are reluctant to use a system which may compromise their ability to control and maneuver the ship, as some fixed installations can. However, for machinery space fires, other options may be severely limited. If a fixed installation of this type is used early enough, it will, in nearly every case, extinguish a machinery space fire and save both the crew and the ship. There's more information about the use of CO2 installations in the Videotel program Operating Carbon Dioxide Firefighting Systems. On board ship, all fires are dangerous, but a machinery space fire is potentially the most serious of all. Frequent and realistic fire drills keep everyone prepared and much more likely to follow their training than panic and put themselves and others at risk. Good fire safety means everyone on board staying observant and sticking to good working practices and company procedures. Remember, you can find more information about the topics we've covered in the workbook. Next, let's briefly look back at some key points from this program. The causes of machinery space fires can include fractured high-pressure oil lines, sparks from angle grinders and welding equipment, overheating high-voltage electric cables, the build-up of static electricity, heat generated by engines, pumps and other machinery, hot surfaces vaporizing flammable liquids, and fuel spillage problems arising from changing over to distillate fuels. Reduce the risk of a machinery space fire by following laid-down working practices, making sure you have the proper tools and authorization before starting any work, and isolating oil or electrical feeds if necessary. Test fire alarms and detection systems regularly. Inspect the fire extinguishers and check the fixed installation. When the fire alarm sounds, you may have very little time before a fire is out of control. Never treat it as a false alarm, even if you can't see any smoke or flames. In an emergency, remember, find it,
Fire! Fire! Fire!
isolate it,
Fire!
report it, and if it's small enough to be dealt with by one portable extinguisher, extinguish it. If it isn't, then E stands for escape. Evacuate unnecessary crew members from the machinery space. Go to your muster station where a roll call will be conducted.
I've just heard from the first.
And finally, the master, the chief engineer and the team leaders must closely monitor the spread and intensity of the fire.
Okay, stop boundary cooling from deck number 1.
Make sure they have accurate and up-to-date information, maintain communication with nearby ports, and make sure they use any fixed installations appropriately. Posters are an effective way of reminding seafarers about safe working practices. There's more information about posters in the workbook. This Videotel program is the last in a series of 5 on firefighting at sea. Program 1 deals with fire prevention. Program 2 with basic firefighting. Program 3 with command and control at the incident. And Program 4 with command and control by the master. Further information can be found in the workbook which accompanies this series of programs.